In this video, we're going to look at what happens and how we can react to situations where we get solver diagnostic messages after an analysis. One thing that I should start off by just mentioning right off the bat is that a solver diagnostic message, which will happen in the solution trail after an analysis, is just the way that SRAM Solver will communicate with you, the user. And it's not necessarily meaning that you have an error in your model. There's three different categories of diagnostic messages. There's FYIs, which is basically just a message that the solver wants to give you, some sort of action that is performed. We have warnings, which could potentially lead to some behavior that you should be aware of, and errors, which means that the analysis won't solve it all. So I would say that A, B, and C, these go in ascending order of severity. It's always good to understand them, however, and we actually have a solver diagnostic messages guide that's built into SRAM that will help you get a better understanding for what these mean. Now, if we continue working with the model that we've been using throughout this video series, we can run our analysis just as is, and we already know from past experience that this analysis will run without issues. So I click OK to run the analysis, and then I'm brought to SRAM solution trail. And this is letting me know that I have 0 FYIs, 0 warnings, and 0 errors, which is great. But that may not always be the case. Let's try to think of a situation where I would intentionally cause my structure to not solve correctly. I'm going to use the example where I remove the supports. So right now I have fully fixed supports at the base of both of my columns, and I'm going to remove them. I'm going to remove them using the control button, clicking down the control button on my keyboard, and then using the support tool, I can left click and drag my mouse around all of the supported joints. And using the control button will basically tell it to do the opposite of whatever that tool would have originally done. So it removed the supports because originally that tool would have added supports. So right now, just to clarify, I don't have any supports on my model. And what's going to happen here if I run my analysis? I go to Run Analysis and run my linear static analysis. And we can see here, now I'm getting a different solution trail. So within this window here, it's letting me know number of errors equals 1. The execution of the solver is terminated. It's not going to run the analysis. And it's giving me an error message, ERR C0048, no structural supports found, execution will be terminated. Because my structure doesn't have any connection to the ground, there's no constraints on it, it's not going to be able to run the analysis. And it's letting me know here that I have 1 error. And I also have this message here. It says, please refer to SRAM Solver Diagnostic Messages document that can be found under the Help menu, Online Resources, to learn what may have caused this above diagnostic messages and what their effects may be and possible recommendations on how to address them. So I'm just going to press any key to proceed. You notice I'm not brought to the graphical results window. If I click on that, I don't have any results available because the analysis didn't complete. But what I can do is I can go to the Help menu, and then I can go to Online Resources. And here I can go to the SRAM Analysis Documents. And if I scroll down to near the bottom here, we have the Solver Diagnostic Messages list. And I'm just going to I've got it open already on another screen here. So I downloaded this PDF file, and I can actually search this for a specific message. So if I want to search for CO048, I can find that message here. I can find the description that the solver gave me, and a more detailed description as well, although this one is fairly self-explanatory. The structure is unsupported, no boundary conditions have been applied, apply appropriate supports, and rerun analysis. So this one's pretty obvious what we would need to do. However, let's find a different scenario. Let's say that instead of having fully fixed supports, we're going to use pin supports. So I'm getting rid of the translational degrees of freedom, or rotational degrees of freedom rather, and just clicking on the joints that only have pin supports in X, Y, and Z. And I'm also going to apply member releases to the beam. So I've left clicked on both ends of the beam, just to clarify what I've got. If I go to Options, Releases, I can see I've released MY and MZ. So if we look at this objectively here, we should expect the model is going to be unstable. Now I can go ahead and run an analysis. I can click Analyze and run a linear static analysis. And when I run this type of analysis here, now I'm getting some different messages. This is giving me warnings and FYIs this time. It's letting me know about a pivot modification that's been made. More details on this are available within that document. It's letting me know it ran through all the analysis, cases and combinations. But what it's telling me here is that I have an FYI SL003, a rigid body mode at node number 2, which we can look up in our model, degree of freedom 6, which is rotation about the z-axis. The degrees of freedom are labeled 1 through 6 with X translation starting, then Y translation, Z translation. Those are 1 through 3, and the same thing for rotation from 4 to 6. So I have 3 FYIs. There's probably other nodes that are also affected by this or other degrees of freedom. And if I look up in my model here, I can see this is node number 2. And if I display my releases again, I can see that the Z rotation is actually released. So that makes sense that the Z rotation degree of freedom, which is degree of freedom 6, at node number 2 would be a source for instability. And this is something that we would need to address. And we can always look that message up as well within the diagnostic messages list. So I can go to SL003, and I can find this particular message and the description related to this. Now this description for this one is fairly long, and you may want to look it up after the fact. But what we would recommend when you do get this sort of a situation, investigate it. Even if your analysis is solving for a linear static analysis, if you plan to do further analysis, you may run into problems. As you go to a p-delta or nonlinear static analysis, the model's behavior is going to be less forgiving to instability.